We've looked at reactions between acids and bases before when we talked about different kinds of reactions. Acid-base reactions or neutralization reactions. So you have an acid and a base, and when they get together they form water and salt. The salt is just an ionic compound. Well, what do we get if we write the net ionic equation for this? Do you remember those? We would have to write the total ionic equation. So we'd have H plus and Cl minus and K plus and OH minus. Anything that's aqueous we would divide into ions. Then over here the water would stay together, and the KCl would be in ions because it's soluble. That's the total ionic equation. Somebody's got the hiccups, it's okay. And then to make the net ionic, we would cross off the spectator ions. So the chlorides are the same, nothing happens to them. The potassium ions are the same. And what do we end up with? Hydrogen ion plus hydroxide ion giving us water. This equation right here. The net ionic equation for many neutralization reactions is H plus OH minus, yielding H2O. This is many, not all. If we react carbonates or bicarbonates, which are ionic compounds containing the carbonate ion or the bicarbonate ion, when we react these with acids, we get a gas being produced. And we talked about these back when we talked about reaction types as well. So hydrochloric acid and sodium bicarbonate or sodium hydrogen carbonate will form water and carbon dioxide gas and a salt. These are called gas evolution reactions because they give off a gas. And you'll see the same sort of reaction if you mix vinegar with baking soda. And that's something that you could do at home. You have baking soda in the little box in the refrigerator, and you mix it with some vinegar, and it'll bubble and froth, and you'll see a lot of carbon dioxide gas. Acids react with metals as well, and we've done some of these reactions in lab. Here is hydrochloric acid with magnesium, and this also causes a gas, and the magnesium is changed into a magnesium ion, and we get a salt out of it. So acids can dissolve metals. So hydrochloric acid will dissolve magnesium and zinc and iron. But some metals don't react with acids. If you react an acid with a metal oxide, like in this example, hydrochloric acid with potassium oxide, then you generate water and salt. Hydrobromic acid reacting with magnesium oxide will get you water and salt as well. And so here the metal oxide, well, I'm not going to say anything. So some reactions of bases. The most important ones are neutralization reactions, but we already talked about those, so we're not going to talk about them again. Another kind is the reaction of sodium hydroxide with aluminum and water. Most metals do not dissolve in bases. Bases really don't do that much to metals, but aluminum is one of the few that does. And so you can dissolve aluminum in sodium hydroxide.